Today we look at the idea of elasticity of demand. There are cases where a change in price can affect how much of something an individual is willing to buy. For example, if it's a good that I need and you raise the price, I'm still going to be willing to buy it. But if it's a luxury item and you raise the price, I may not be as willing to buy it, and so the demand is going to decrease. The concept of how this change in price affects the individual's ability or willingness to buy a product is called elasticity. You'll see here the formula for elasticity of demand. Remember that the demand function itself is an expression of price, and then the derivative is also important for the elasticity function. There are three scenarios to consider with elasticity, and it creates a relationship between revenue, since revenue and price are directly related. If you remember, the revenue is equal to the number of items sold times the price, or the number of items sold times the demand function. So elasticity and revenue are directly related to each other. If you calculate the elasticity and it's greater than 1, then we say that the demand is elastic. In this case, if we raise the price, there's going to be a decrease in total revenue. However, a decrease in price is going to result in an increase in total revenue. These are typically luxury items. If the elasticity is less than 1, we say the demand is inelastic, meaning it's not going to change much. In this case, an increase in price is going to result in an increase in total revenue. We're still going to buy the goods, even if the price goes up. But a decrease in price is going to result in a loss in total revenue. And these are typically necessary items, things that we have to have. And the final scenario is if the elasticity is exactly 1, it indicates that the demand is unit elastic. In this case, revenue is already at a maximum. If you look graphically, I think it helps to understand what's happening here. This top curve here shows our price with quantity. Remember, as the price goes up, traveling in this direction on the curve, the quantity that folks are willing to buy typically goes down. But notice here, as we compare it directly over revenue, if we're in a situation on the left side of this line, if we increase the price and come down to the same position on our graph in revenue, an increase in the price takes us down on the revenue curve. So for elastic goods, an increase in price decreases revenue. It's a luxury item. You raise the price, I don't have to buy it. However, if we come down here to where something is inelastic, an increase in price puts us here on the revenue curve, bringing us up the revenue curve. So an increase in price increases total revenue. It's something I have to have. It's not a luxury, it's a necessity. Let's look at this mathematically. First of all, suppose we have a demand function where the demand is 300 minus 2x. Remember, this is price, so if we want to know the price, we simply take the demand function and calculate it for 50 units. So we're going to have 300 minus 2 times the number of units that we're selling, which gives us 300 minus 100, or will result in a price of 200. Let's now find a function that describes the elasticity. Remember, the elasticity is negative 1 over x times the demand of x over the derivative of the demand. So if we take that demand function that we already saw, which had a value of 300 minus 2x, we can go ahead and calculate the derivative, which gives us a value of negative 2. Plugging these into our elasticity function, we get negative 1 over x times 300 minus 2x over negative 2. The negatives will cancel each other out, and we get an elasticity function of 300 minus 2x over 2x. And if we simplify that by dividing everything by 2, we get an elasticity function of 150 minus x all over x. Now we can calculate the elasticity at various numbers of product being sold. If I wish to calculate the elasticity of 50 items, I'm going to do 150 minus 50 over 50, which gives me 100 over 50, or 2. This is greater than 1, so this is an elastic situation, which means that it's a luxury item. If I raise the price, then my revenue is potentially going to go down because people are not as willing to buy. If I calculate the elasticity of 100 items, when 100 items are being sold, I do 150 minus 100 over 100, which gives me 50 over 100, or an elasticity of 1/2, which is less than 1, indicating, since it is less than 1, that it is inelastic. It's a necessary item. Raising that price, I'm still going to buy things. My revenue is going to increase. It's going to decrease if I lower the price. So to find out what quantity maximizes revenue, I'm going to take that elasticity function, which was 150 minus x over x, and I'm going to set that equal to 1. When I do that, I multiply both sides by x to give me 150 minus x equals x. Add x to both sides, and I get 150 equals 2x, or x equals 75. This is where I'm going to maximize my revenue, is when I'm selling 75 items, which directly affects the price that I'm going to be selling them for. Remember, if we look at our revenue function, we can confirm that this is indeed a maximum revenue. Our revenue is going to be x times the price, and the price is the demand function. So our revenue is 300x minus 2x squared, giving us a first derivative of 300 minus 4x. I want to find where that maximum exists, so I set it equal to 0, or where my extrema exists. So I get 300 equals 4x, or x equals 75. Now, confirming this is not a minimum to show that it's a maximum, I can look at the second derivative, which if I take the second derivative of revenue, I get a -4. Since the second derivative is negative, that does tell me it's concave down, indicating this must be a maximum.